Wij gaan back to the future.
Jan en ik gaan op 17 april naar de Microsoft Technologies en .NET conferentie van Nederland. FutureTech 2024 in de Jaarbeurs Utrecht.
Hey, weet je wat echt super tof is?
Nou, vertel.
Wij mogen gratis kaartjes weggeven. Wat moet je ervoor doen, Ronald?
Nou, dat is heel simpel. Volg ons op TikTok. Daar zijn wij tegenwoordig ook te vinden.
Vet, hoor.
Ja. En op YouTube en maak kans op 2 van deze tickets.
Ja, vet. Hey, mis je kans niet en dan zien we jullie daar.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben uw gastheer Ronald Kers en ik zit zoals altijd met de enige echte...
Jan Stomphorst.
Nou, wat een enthousiasme weer, Jan. Op de eerste dag van KubeCon hier zo.
Zo, nou, ik moet wel zeggen, ik heb nog heel weinig gezien. Want we zijn alleen maar op opnames aan het doen.
Ja, we zijn alleen maar opnames aan het doen met hele toffe gasten. Super toffe gasten. Gooi er nog even in.
Dus we zitten hier met...
Markus Flierl. Welkom Markus in our podcast.
Dankjewel. Nice to be here.
Oh, he knows Dutch.
This is the extent of my Dutch.
Okay, thanks for
Exhausted my vocabulary.
Well, thank you for taking your time to joining our podcast. And can you please introduce yourself to our listeners?
Yeah, thank you for having me. My name is Markus Flierl. I work for Intel. Joined Intel just over 2 years ago to lead Intel Developer Cloud and Intel Cloud Services. And that also includes things like Granulate, our performance optimization service. And prior to coming to Intel, I was at NVIDIA. I had built out NVIDIA's GPU cloud infrastructure, which was the foundation for things like NVIDIA's GFN cloud gaming service, also for Omniverse, NVIDIA's answer to the metaverse, as well as some of the large AI clusters.
Okay,
Cool. You would like gaming.
Yeah, but it's something different than the DGX platform, right?
The DGX, so for cloud gaming, we would have lower end SKUs, and for the high end, for the training, I was building out with DGX box.
Oh, okay. And how did you get started in the IT?
Before that, I was at Oracle, and before that, I worked for Sun Microsystems, actually, working on Solaris, the Solaris operating system.
Now you got his interest.
Me too. I worked on Solaris. Not for Solaris, but I worked on a lot of Sun systems.
A lot of us started with Solaris.
Yeah, it's awesome.
Yeah, he's a few years older than me, but I missed that. Somehow I missed that part.
And they started with containers already.
Yes. 2005 in Solaris 10 we introduced them. We called them zones actually. It was in pre-containers, and it was more of an not so much of an application container, but like an OS container.
Yeah, an OS container. I used it in my. I was working in trading systems, so we used containers there.
And also I was working on virtual networking with Crossbow. Introduced layer 2 network virtualization as well. This was pre-SRIV. Dating myself here.
Cool stuff. Yeah. So you had a talk here, American Airlines Above the Clouds. Can you share with us and our listeners what you talked about in that talk?
Yeah. We had a joint talk and talked about how they are using our Granulate, Intel Granulate optimization service. So Granulate does, it's a cloud service. It's fully autonomous. And what it does is we profile the customer's workload. And based on what we're seeing then with profiling, we will then apply various optimizations. Some of the optimizations we apply, we can optimize data lake, workloads like Databricks, for instance. We can optimize that. We can optimize Kubernetes-based workloads. And what we do essentially, we profile the containers that are being used. And in some cases, it's over-provisioned. And then we can help shrink that down in order to reduce the cost. But oftentimes we increase the performance of the workload.
Interesting stuff.
How do you profile those systems?
Yeah,
what magic is there?
So the other thing is runtime optimization, for instance. Let me talk about that. So for instance, like you have a Java workload. Right? And so Intel, we have thousands of engineers doing all kinds of optimizations. And oftentimes it takes a while for these optimizations to go upstream and then to show up in an enterprise release. What Granulate does actually would detect some of these inefficiencies. And like, for instance, if you have let's say a custom Java workload, you build your own Java application. But we find that there's a newer library that's available. And then we'll actually modify the runtime, and we will use the more efficient library in order to speed up your workload. And so the benefit then is that the workload will run faster, but at the same time it also reduces the rest resources, which is very non-intuitive. Like, I add more resources, I get more performance out of it. But in this case, we're just purely driving the efficiency, which means that you will see faster response time but at the same time, you're also reducing your cost. And especially in the cloud, that cost savings shows up immediately. And so that means, in their case, they were talking about their Databricks workload, data lake workload, for instance, that they were running. And they were able to shrink down the footprint by almost half while increasing the throughput by 20%, for instance. Right? So it's tremendous savings. And same thing also with Intel in our own environment. Of course, we're also applying that. We're also able to shrink our footprint down by almost half as well with our data lake, actually. So significant savings, especially with cloud costs. Right? Cloud is easy. I go in, I run my workload, and then the workloads grow. Especially with analytics, with data lakes, so we're continuously collecting more data. We want to, we're building out more fabs. We're collecting more data from all these fabs, and we need to process that, and that drives up the cost. And by using Granulate, we're able to really shrink that down and to dramatically reduce the footprint. And similar things with Kubernetes, since we're asking. Also, with Kubernetes, we will then profile the workload. We'll make sure that we still meet the SLA, obviously. We don't want to just slow down the application.
No, of course not.
But then we would, for instance, switch around between different, in a lot of cases, the containers they're using, there's too many CPUs allocated to the various containers that they're not really fully utilized. So we'd actually shrink down the amount of CPU that's being used while maintaining the memory. For instance, in other cases, there's too much memory provisioned, so we'll actually reduce the memory. So it's really that right sizing between memory and compute, for instance, that we can apply.
But are you using, is Granulate doing monitoring on the resources to get that profiling running? Or how do you profile?
We have it's called Qi Profiler, Granulate Profiler that they're applying. And the Granulate Profiler will then instrument the workload. With obviously it's very efficient, so you're not seeing any performance penalties or anything, or very minimal penalties. We profile the workload, and then based on what we're seeing from the profiling, and we can visualize that. That's the other thing.
Is that running in the container, or is that where's?
Correct.
Oh, it's running as a side pod, or is it running in the program? Do you need to put that?
No, you don't need to change the code. It's profiling the container. It's looking at what the container is using and what the utilization is, like your CPU utilization, and then it will actually take that and will actually optimize that accordingly.
And that's running in Kubernetes somewhere, and it's getting those metrics from Kubernetes.
Yeah, so we use the existing APIs, so there's no additional. You don't have to change your code. You don't have to rewrite your code or anything like that. Similar with the JVM, we'll essentially profile the JVM itself, and based on that, we will then dynamically apply some of these new libraries that will then speed up the workload.
Are you changing then out the memory for JVM, like the heap for the memory for the Java memory?
Not changing out the heap per se, but we're just tuning the JVM essentially, right? We're tuning it, and we're modifying the runtime of the JVM, where you utilize more efficient libraries that will then reduce the amount of the footprint, the CPU footprint, for instance.
Yeah, and if you changing out libraries, how can you know that the libraries are good and doing the same thing?
So the change of libraries. Obviously we have our own validation environment.
Yeah, of course. But if we want to use that,
So essentially,
changing libraries is always risky business.
It's risky, but when we make those changes, a lot of those libraries already like in a newer version of the JVM, for instance. Oftentimes, if today you have. I think we did stats sometime that over half the customers out there still running on like Java 8 workloads, right? And so there's been a lot of optimization already happened in the upstream, but it's just not available yet in those older versions. And oftentimes you're forced by your application. Let's say you have a packaged application, you cannot just upgrade your JVM, right? You have to have agreement from your application vendor to make sure that that's the approved version that's fully validated.
Yeah.
And so, but so those optimized versions already exist in many cases, and then we're not changing the behavior of the libraries. We're just using a more efficient way of processing that. So functionally, we're not changing the functionality. It just means that in some cases, it's just a more efficient implementation of that library, and that's how we're achieving those.
But sometimes the newer library is slower than the foremost library. Is Granulate not giving that advice then to use a newer library?
Correct. Again, a lot of this is we have done a lot of validation testing on our side to make sure that we're not slowing. That's a good question. Yes, totally. Yeah, oftentimes what happens is new functionality gets added and all that. But we've done a lot of profiling. We looked at different workloads. We do this at a very large scale. So we find those are the libraries that give us the biggest bang, the biggest improvements without those kind of corner cases where you may have a slowdown effect as well.
It's not a corner case in my world.
Okay.
And are you constantly doing checks on new libraries?
Correct. It's an autonomous service. Essentially, you enable the service, and as we find more improvements over time, then we can continue to optimize your workload going forward. And it's not just a one-time optimization that we do that gets pushed out, but it's a continuous. It's a service that you subscribe to that will constantly look for enhancements. So as we find new enhancements, or as Intel also, we do a lot of optimizations, for instance, around Kubernetes. Right, we're constantly looking for a better way to do auto scaling, for a better way to drive efficiencies, and Granulate gives us an outlet to make those enhancements available ahead of, again, changes going upstream and then coming back downstream into a commercial version. So with Granulate, we can actually make some of these enhancements available to our users early on.
You gain speed and the costs go down, but that's also the less resources you use is also, I think, a big part of sustainability.
Yeah, in fact, one of the things we have a counter actually, where we can actually quantify the amount of CO2 savings that you're getting based on the number of cores you're running. Yeah, of course, if you're running, some workloads, you're running thousands or tens of thousands of cores, and all of a sudden you just, you're saving tens of thousands of cores. That's a lot of energy, a lot of CO2 that you're burning. Absolutely.
Yeah, it's going to be a sustainability week somewhere in October.
Well, every week is sustainability week.
Of course,
saving CO2.
And are you using? You're doing also new libraries, but if I write a library somewhere on GitHub, can I add my personal library also there?
Correct, of course. Yeah.
Or just any library?
You can. I mean, it will have to come through over time. Yes. I mean, this will, as new functionality, as improved libraries show up, we will actually, detect them, and then we will include them in our service. But you're asking, can you do this dynamically, on the fly?
I'm just writing a new program and I'm using libraries from a friend of mine, for example, and he's writing new libraries there faster. I'm not sure. You're recommending me the new library, hopefully. So are you scanning GitHub then completely, or how do you find the new libraries?
It's basically, once they become available as a more more mainstream. But I think you're raising an interesting point. I think the question that goes in my head, that comes to my mind right now, is that could we actually open this up as a service for developers, so developers could live test that and see, that's an interesting thought, actually. You're giving me an idea there.
That's always good. That's always good.
It's on record now. So
it's always because the mainstream. We know the mainstream things, but I use always also not mainstream software because I'm from the corner cases.
Bij ACC ICT staat alles in het teken van continuïteit waarborgen voor bedrijfskritische applicaties. Of het nu gaat over Managed OTAP, Cloud en Kubernetes, ze geven hier invulling aan om door samen met hun klanten een toekomstbestendige strategie uit te stippelen voor het gehele proces van ontwikkelen tot en met productie.
Another thing that might be interesting also, since you're interested in developers, is combining that also with the latest and greatest hardware. One of the other things that I also lead, aside from Granulate, is the developer cloud team. And so the other thing you can do is also, as a developer, you can actually come in and you can get access to the latest pre-production hardware. And you can actually then write a library that's optimized for the new hardware. For instance, we have our next generation Sierra Forest product line that is going to be shipping later this year.
Without hyperthreading?
Yes, correct. With the e-cores and all. And we already make that.
Do you know why you stepped off hyperthreading for the Intel processors? Because it was, I think, 10 years or 15 years in there? Long time?
Yeah. I don't know all the details why that was decided. But essentially, what it allows you to do is then have a peek into the future to see, what the hardware is arriving in 6 or 12 months from now. and you can do your optimizations. You can start optimizing for that today. And also like the latest, Java optimizations or the latest Linux optimizations. We have the latest software and the hardware components in the developer cloud, and you can take a peek into the future.
And that's awesome to optimize your software for the new processors, because they changed a lot.
Yeah, of course. Yeah, with the Sierra Forest product line, essentially it's focused on throughput computing, right? So it's much closer to like an ARM architecture in some ways. So we have the high-end architecture, which is really focused on the performance, and then the lower one is really focused on throughput. Right? It's really optimized for power consumption and for raw throughput.
And raw throughput, and is that optimized then for container workloads?
Yes, of course. Yeah, we're doing a lot of optimization as well for that. So essentially, it's optimized for any workload that is parallel, that you can fan out to a lot of cores. So with Sierra Forest, it's going to have 144 cores, and then obviously, it's rapidly
in one processor.
Yeah.
Wow.
When is that coming to my laptop?
Yeah, we'll need to work on that.
I want that in my laptop. I use a lot of CPU on my
I
laptop.
think your laptop will be a little bit bigger.
Bigger.
Probably.
No, it's actually very, very power efficient, so it may not be that bigger, because sometimes the size of the equipment, both laptop as well as the servers, of course, is determined by the amount of cooling you need.
Sure.
Right?
Yeah.
And by this just being really performance power optimized means that it's pretty efficient. So you get a ton of compute power for very little power.
So if people want to get started with Granulate, where should they begin?
It's through the cheap profiler. We have the cheap profiler that you can just download, and you can just instrument your workload. It's very much of a self-service. You can just test it out, and then of course if you want to hook this up into a production environment, then just reach out to the Granulate team, granulate.io, and they can set you up with that.
Okay.
But, just to do an initial exploration with a cheap profiler, they can do this immediately. It's self-service. They download it. They apply it on the workload, and that gives them a starting point.
Okay.
And is that then free?
The cheap profile, yes.
The cheap profile. So we can start for free, and then if you want more services, of course, you have to pay.
Yeah, but how big must my company be, or the development team be, to start?
There's no minimum size. You can just download it. And then the other thing is also the way we charge is actually it's a fraction of the savings actually. Right? So we don't charge you up front or anything. It's just once you start saving, then we take a share of that.
So there was a big share at the flight company of the airline. Mm-hmm. That's awesome.
Yeah, no, it's they're running it. I mean, of course you have a lot of the data for like collecting a lot of data, right? There's a lot of flights, there's lots of people, a lot of
that's a win-win at that point.
That's right. So it's you can't lose basically. It's like you only pay when you're seeing the savings. So it's very easy for us to demonstrate the value. A lot of other IT projects, like you give us all this money up front and then you pay later, and then you get the benefits later. Here it's like, no, you're not going to pay until you get the benefits.
Now you can see the benefits, and then there's a percentage of that you pay.
Yeah,
you can see the effects immediately.
And then the other thing to consider here, to note here, is that it's obviously it's nice when you save a bunch of CPUs, but you will also, a lot of the software is also priced per core or per socket.
Mm-hmm.
So if you can shrink down your workload by half, not only are you saving all the compute power and all the compute and all the infrastructure cost, but in a lot of cases it means there's significant savings on the licenses.
On the licenses too, yeah.
In a lot of cases that can outweigh.
You cannot underestimate that part of
exactly.
of the costs.
Yeah, I use Linux. I don't do your licenses, but Solaris had their licenses. But yeah, no, you've got Open Solaris now.
So where do you see the future of Kubernetes?
I mean, it's so prevalent at this point. It's just amazing how I think I first started working with Kubernetes my Solaris days. Actually, we started introducing Docker containers. This was almost a decade or more than a decade ago, and it's just amazing how far it's come. I think the big opportunity, I think, for it is also like obviously to run containers, but I think there's also a lot of opportunity to do more virtual machines. I think a lot of that is still running in proprietary environments, and I think there's a lot of opportunities. And also for within the developer cloud, for instance, we're also using KubeVirt as a way to also run VMs as well. And I think that's a big opportunity for Kubernetes to grow into. And other than that, I think there's just more sidecars and a lot more of the security functionality. I think to me a critical area where it's just gonna, especially with AI, I think the threat vectors that we're seeing is just gonna growing exponentially, I think. And I think that's something where, again, from a defensive perspective, I think we're gonna see a lot more need for security also. And we also have with Intel, we have the Intel Trust Authority, which means that you can actually run your containers in a what we call the trusted domain extensions, which means that you can run it and you attest to the fact that the hardware that you're running on, the chips that you're running on, is actually the chips that you expect to be running on. Software that you're running on is also fully attested for, meaning that so you're excluding a whole range of threat vectors where somebody has interjected malware into your infrastructure code and they're reading out data and you don't even know it. You have all your network is encrypted and all your storage is encrypted, but people can still read out your data from your container potentially.
Is that on the Intel cloud?
Or that's a generic functionality that we make available. So yes, we have it available in the Intel cloud, of course. That's where we always the first place where we do it.
Yeah.
But we're also working with all the CSPs. We already have a beta now running with Azure, and we're seeing a lot of interest from a variety of customers. Not just the ones doing super paranoid ones, but really a broad range of customers.
Yeah, we do it for banks and other.
Just another question that popped into my head. Granulate does performance monitoring on this CPU and a memory, or a CPU.
CPU and memory both.
CPU and memory.
Optimize the ratios.
Ratio. Are they also looking in the GPU, because GPUs are getting more and more important in the AI space, of course?
Nothing that I can talk to here, but it's an area that. For now it's very focused on CPUs, but I agree with you. I think that's, especially in the GPU space, the nice thing about GPU, get all this raw compute power, but then, a lot of times the utilization is not that great. And people look at this like, I spent all this money on these expensive GPUs and they're consuming all this power, but I'm not using that more efficiently. So absolutely, that's...
Yeah, because Intel also has their ARC GPUs, right. So I can see there... Also. Yeah, of course. So I can see there's something happening there in the future.
Nothing I can talk
maybe,
right now.
Of course.
No problem.
Sure. Well, Markus, thank you. Yeah, thank you very much for taking your time to have a chat with us, and we will follow the development of this platform with very close eyes. Thank you very much.
Thank you well.
Thank you.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple, Google Podcast en alle andere favoriete podcastproviders.